Alright, welcome back to another episode of KillerRabbit Codes. We'll continue where we left off. I did, off camera, add some documentation and completed a few other things that I realized I missed. So, today we'll be working on the low-level version of this. So we're gonna create a new split, and then go mod low. And this is gonna have much more of the lower level features that we're looking for. So we will go ahead and create load.rs, write it, and so this will have the structure that we need for at the low level. Let's see. Where are you in my notes? Alright, on my notes. Alright, so let's write our header. So we'll actually have fields. And the layout will be so we need a magic number, a U32, and then a major, which is a U16, a minor, which is also a U16, and then a section count, which what this will be used for is it'll tell us how many sections there are in the file. Sections being like the types, the functions, the bytecode, because we may not need all of it. And then we want the string table offset, which is how many bytes into a module file where the string table, where the strings live. And then we need the size so that we know exactly when to where it begins, so we can skip over it if we need to. And a few other things is we want a file source, which is just another U32, which is just a string in the string table that tells us which string is the path to the file. And then let's see, a start function U32, which both of these are one. I should probably write that down. One index. The reason we have to do one indexing is because we need a way to represent the fact that there may not be a file source, and that the start function may not exist because it doesn't have one. So let's see. So this together is 164, 264, 564, and then we need one more U64 to align it. So let's call it padding. Call it. Next step is the section table, which defines how sections are defined. So, so to do that, we'll probably have to define a bit flags. So. Actually, I don't think we need a bit flags. Actually, we just need a ripper. U32. Section descriptor. We need a string table. I think the syntax is this. This is a section kind. This will be I'll need pub. Here. The kind, which is a section kind, offset, which will be a U32, and then the size, which is how big it is. And so we'll have as a type table. Alright, so this one variant, and then we have we also only support up to 120 200 not 100 256 different ones. So fields count is a U8. We have padding, probably public. Keep them all. Yeah, the padded, so now they can keep aligned. And so, or they keep alignment. And then types, and this is a vec that shares the length of the field count. But I'm gonna make this an I32 because that's just how we index types. And so that should cover that. Now we need a, what should we call it? What's next? The effect table. And then table, which will be effect entry. And it will be a U32. There's one indexed. Op count will also be U8. And then for alignment purposes, we need another padding U8s. Because what will happen is when we convert this back from binary, Rust will want the pointer to be, when we start pulling up slices, they'll want us to be aligned. So it's just easier to keep it aligned and then just convert it back into a vector when we're parsing it. That's just my experience. That's what we're doing. And at the end of the day, it's not that hard to remove the padding if we don't need it. Now we need operations. Operation. And so we have the name. And then we have let's see. There's a design branch we can pick here. Is what we can do is whenever we compile something, say there's multiple state effects, we can make it so then each state effect is its own unique effect in each function whenever it gets masked. Well, masking is pretty straightforward. But it's more or less when we have multiple overlapping state effects, how do we deal with them? Do we make them a unique effect for each thing and then that just works? Or do we make the effects more generic and so that we can split them? I think they should just be unique per function. So if I create a new state effect, it should be a completely different state effect. Which some might disagree with that, but I think it's saner. It means the compiler has to do more work, which I'm not the compiler, so I can do whatever the heck I want. So I'm going to go with that. And if someone who knows way more about algebraic effects than me, who thinks that's a bad idea, please chime in. Otherwise, I will go with this. No, I already did that. Arg count is also U8 because we only go up to that many arguments. I think padding probably should be public. Not that it really matters what is in there. This is completely wrong. This up here is very wrong. And then, as you remember earlier, we support return types. So, that's one thing. And then, let's see. All right. And the function table. All right, so count table will be rec of function entry and let's see, what do we need for this? I keep doing that. I need a kind should be a kind defined down here. Make it a U8 for function kind, and it would be just a function closure. And so now this is a U8. So now I need to keep it aligned. So we need the parameter count, which will be U8. We need a little bit of padding, so make that a U8 2 actually. And then let's see. Oh wait, hold on. I can do this. Oops. And then we need a pub effect count. And so with effect count, actually, we could probably use this. Let's do a U32 because that's sufficiently big. I don't think we need that much. Like a U16 might be excessive. But U8's probably far too small. So, let's do a U32. This just indexes into the effect table. And then, oh yeah, I guess if we're a closure, there's a little bit more information that we'll need. Because it makes sense to know our up values ahead of time. Which I guess we could just do that. There we go. Now we got some pretty compact packing. And then, oh yeah, here's the thing obvious that I didn't think about. Here's a thought. Eventually, I want to have a foreign function interface of where we can pull symbols out of the virtual machine and call them, or out of a. Let me start over. Eventually, on a foreign function interface to where you could program in, say, C or even Rust, and then you could basically do stuff like you can start manipulating, you creating your own objects and manipulating them. And to do that, we need to know exactly if a function in here is implemented in bytecode or is actually in a external library. And so we need a way of identifying as like, hey, is this found somewhere? Because what I was thinking of doing is we could have do it two ways. I was thinking like, we have negative numbers. That could be like, oh, just look that up in the string table. And then that's the function you pull out of a shared object. Alternatively, if it's 0, we just pull the name out of the shared object. I personally like pulling the name out if it's 0, so is the byte code. Index will be a U32, and this will also be one indexed. And so the bytecode table actually will be pretty much identical to the string table. There's a typo here. So yeah, and so we'll just, the function entry indexes into the bytecode table, and then the bytecode table goes and fetches things. And so what's next in our things? It's probably the stack map. Yes, it's the stack map. So count as the U32 pub. Let's call it entries to be weird. Entry. And so stack map entry contains the following things. Which we should actually put we should probably put that some of this information probably be in function entry. So do map index via U32 is a also U32, I guess. And so we need a parameter, which is where we are in the code. And then we need the mark which items in the stack are safe or are heap allocated. Which we'll make the assumption it's from where we last know the stack in the interpreter for that frame. Because realistically, the stack map's only useful for once we like go through each frame and start messing with things. So we'll need a class, and this will be a bit vector. I'm gonna say it goes to I would say that the stack for a function should not exceed 64 bits or 64 slots.